What makes data visualization a bit different from other types of animation is that some component of the visual, some aspect of the visual is directly based on some type of science data. So in the case of the tour of Asteroid Bennu, the OSIRIS-REX trajectory is actually based on mission data. The model itself, the asteroid model, that is real LiDAR data that was collected from the OSIRIS-REX spacecraft. The imagery that you're seeing wrapped to the surface of Bennu, that is actual satellite imagery taken by the spacecraft. And so that's kind of the difference between visualization and animation, is we're showing the real data. This is the real asteroid. So if we zoom all the way in on a boulder, that's the real boulder. That's what it looked like from the perspective of the spacecraft. I'm Kel Elkins, and I was the lead data visualizer on the tour of Asteroid Bennu.
I'm Dan Gallagher. I was the producer and writer on the tour of Asteroid Bennu. Tour of Asteroid Bennu was inspired by an earlier video that was also made by NASA's Scientific Visualization Studio, and that video was called Tour of the Moon. The visualizer, Ernie Wright, used elevation data and high-resolution imagery from a NASA spacecraft called the Lunar Reconnaissance Orbiter, and he was able to fly the camera very close to the lunar surface and show the actual textures, shadows, highlights, just the way that they would appear if you were hovering close to the surface of the moon.
So we kind of borrowed some of those techniques for the tour of Asteroid Bennu, really using lighting as a way to help viewers understand the shape of Bennu and the shape of these different geological features we were zooming in on, which just it really helped the visualization come to life.
So a good example of how we use LiDAR comes about halfway through the video when we take viewers to a boulder called the gargoyle. Now the gargoyle has a very complex, amorphous shape, and it looks really different when you see it from different angles in two-dimensional photographs. But when we finally got a good 3D model of the gargoyle, Kel was able to put a virtual camera down near the surface of Bennu and rotate it around the boulder in a way that we never could with two-dimensional imagery.
So something really cool about working on this particular visualization, and actually all the visualizations we made for the OSIRIS-REX mission, was as the spacecraft got closer and closer to the asteroid on its way there, and as it spent more time studying the asteroid, the models got better and better. The data that was collected was getting better and better. So some of our early visualization tests, we had this relatively low poly model of the asteroid, and we could only push in so far with the camera. You can't push in too far because then you just see individual polygons. But as we got further and further along, we ended up with 5-centimeter resolution tiles that you could push all the way into individual boulders. And that's just the nature of how these science missions work. The more time you spend with something, the more data collect, the better the models get.
Missions like OSIRIS-REX take us to places that we haven't been before, literally new worlds that we've never experienced. But they show us those places in ways that can't always be easily seen. Tour of Asteroid Bennu gives us a way not only to show the public what these places are like, but it almost gives us a remote presence. It allows viewers and even scientists on the mission to see these objects up close through technology.